Hello and Assalamualaikum everyone. In this video, I will present about one of the method in solving the system linear equation with three variables. The method known as Jacobi iteration method. But in this section, I will explain the solution, which is solved by handwriting first. First, look at the system linear equation as shown above. From the equation, I will explain briefly about the process of Jacobi iteration. First step, we will start out with a guess for the unknown x1, x2, and x3. And we will insert that number into the system of three equations to obtain a new result for each of those x1, x2, and x3. Then, that new result is put into the same system again to get another new result and so on. We will keep doing until the value of x1, x2, and x3 approaching the solution of the system. Hence, please look at the linear system above. So, let's start with the first step by rearrange the equation by solving the first equation for x1, second equation for x2, and the third equation for x3. Next slide. Second step, we must state the initial estimate, and usually we state 0 as its initial value. For the step 3, we proceed to the next step, which finding the first iteration. By substitute the initial estimate value, which is 0, to each equation, we get the new value for x1, x2, and x3. Hence, the value for the variables are being using for finding the second iteration. So for step 4, find the second iteration. The step must be repeated until the value are approaching the solution of the system. This is step 5 and step 6, which is we find the third iteration and fourth iteration with the same process. Here are the table of the iteration. By this table, we can see the value are approaching the solution at iteration 12. This is because the value of x1, x2, and x3 is going to get the same at iteration 12. And it also means the solution is exactly approaching the solution. In the other word, the closure of Jacobi iteration method had been occurred. So, that's all for me. In the section of handwritten, I will pass the next section to Sangeeta. She is present about using Mathematica.
Hi and good day to Dr. Nurul and my fellow friends. So here I am Sangeeta Puvanesan and I'm going to be presenting about task 2 where I have used Jacobi method to solve matrix A in a software called Mathematica. So as you all can see, I've defined A as the matrix A as per shown. So the first curly bracket consists of the first row of the matrix A. The second curly bracket consists of the second row of the matrix A, and the third curly bracket is the third row of matrix A. So B I defined as the right hand side of matrix A, and the third row you can see that I have defined x1 as 0, 0 and 0, whereby I use the initial condition as 0, 0 and 0. Alright, so D1 is equivalent to diagonal of matrix A. So I wanted the diagonal of matrix A, which is 5, 9 and negative 7. So next, as you all can see, I've defined D2 as the diagonal matrix, and in the bracket I've put D1, whereby I want the diagonal that we found earlier into a matrix form. So that's the reason why I wrote this command for me to obtain the diagonal in the matrix form. So next, as you all can see, I found the lower triangular rise of matrix A, but I have minus it with the diagonal matrix. Why I did so is because I want to find the strictly lower triangular rise of matrix A. I only want the lower triangular rise of matrix A, which doesn't consist of the diagonal matrix. So the third one, as you all can see, I wrote the same command but to obtain upper triangular rise of matrix A, and again I've minus with D2 for me to obtain a strictly upper triangular rise of matrix A. So here you all can see I wrote that L is equivalent to negative of the lower triangularized matrix. U is equivalent to the negative of upper triangularized matrix. And here ID is the inverse of the diagonal matrix. So here we will get the output as below, which is 1 over 5, 1 over 9 and negative 1 over 7. So now you all can see that I'm showing you the command, which is the do loop command for us to obtain the iteration. So I have wrote the command using the linear solve. Alright, so here you can see that I wrote print n equivalent to matrix form. I want the iteration to be in a matrix form, and lower below there I wrote n, 1 and 15 because I want to find until the 15th iteration. So now I'm going to show you my iterations that I've obtained once I run the coding. So you all can see that I have shown here starting from iteration 1 to iteration 15. Just by observing these iterations, we can see that the 12th iteration converges, right? So you all can see that starting from iteration number 12 until iteration number 15, we can see that we obtain the same matrix. In this case, we can conclude that, or we can say that the matrix A converges at the 12th iteration. So that's all from me for this task. So thank you.
Good day to our beloved lecturer and my fellow friends. Today I'm going to solve one of the equation given using Gauss-Seidel method. So first of all, we have to rearrange the set of number given into a matrix form. So for first set of number, which is 5, negative 2 and 3, we have to put in the first column and followed up by the second set of number and third. So we will get one set of matrix, and for the number in set B we have to arrange and put in a different set of matrix. So finally we will get the one set of equation like this. So after that we have to solve the equation, so we will get the equation specifically for x1, x2 and x3 like shown in this slide. And then the initial approximation is fixed as given in the question, which is for this question is fixed as 0 for three equations. So after that we have to substitute the initial approximation given into the equation we will get for the x1, x2, x3 before this. So after substitute we will get for x1 we will get negative 0.2, while x2 we will get 0.155556, and for x3 we will get negative 0.507937. After that we will do the iteration for the second iterations. So for that we don't have to substitute the initial approximation given, while we have to substitute the values we will get in the first iteration for x1, x2 and x3. So after substitute the x1, x2, x3, we will get for x1 we will get 0.166985, while for the x2 and x3 we will get 0.334321 and negative 0.428622 respectively. This is also followed by the same method of substituting the x1 value we will get with the previous values we will get. Actually this is for the third iterations. So for this question we will get the iteration until number 10. uh, the thing that we can observe from this iteration is the iteration for this equation is this will stop at number 8 actually. This is clearly we can see by by the repeating of the number we will get. We will get the repetition of number in iteration number 9 and 10, like we get in number 8. So we clearly can see the iteration stop at number 8. The comparison between Jacobi and Gauss-Seidel is the rate of conversion of Gauss-Seidel is roughly twice than Jacobi. This is because Gauss-Seidel method utilizes the most recently updated value of unknown variable, leading to a faster conversion rate. The Jacobi method also updates all the variables simultaneously using the values from the previous iteration, while the Gauss-Seidel method updates one by one using the values in the current iteration. The last one is Gauss-Seidel method also uses indirect method, while the Jacobi uses the direct method. That's all from me. Thank you.
Hello and good day everyone. So I'm Kishantini Loganathan with the metric number of D202010957885. Okay, so today I'm going to explain more on the Gauss-Seidel method using the Mathematica software. Okay, so as y'all can see, this is the question that is used to do the Gauss-Seidel method and also the overall questions, the overall solutions as well. Okay, so for the first one is the coding that is used to solve. Okay, so as you all can see, the main five items that is used is the A, the value of A, B, the initial, tolerance, and also the max iteration. So as you all can see, I've inserted the A's value as below and also the B's value. And then, as you all can see, the initial x theta, okay, the initial is 0, 0, 0, and the tolerance, which is 0.001, and the max iteration, which is 50. Okay, not only that, as you all can see here, I have substituted the word iteration with the word iter. Okay, so as you all can see, I've inserted iter here and also max iter. So as you all can see over here, the maximum number of iterations that has been reached and also the solution has converged in iteration. So the word iter here will be substituted with the number of iterations that is produced later on. Okay, so as you all can see, this is the overall coding that is used. Okay, so this is the solution from the question before this. So the solution has converged in 5 iterations. So this is the answer, as you all can see. Okay, next, so I'm sure that you all have seen the Jacobi method using Mathematica software before this. So let's compare that with this Gauss-Seidel solution using Mathematica software as well. Okay, so for the first one, we all can know that both the Jacobi and Gauss-Seidel method are iterative techniques for solving linear systems, but they also differ in how they update the variables, as you all can see before this. Okay, so there are actually main 3 comparisons that I've actually seen here. Okay, so for the first one is, as you can see, there are 5 iterations under the Gauss-Seidel, whereas there are 15 iterations under the Jacobi method. Okay, so for the next one, as you all can see, is the Gauss-Seidel method tend to converge faster than the Jacobi method, which means that it usually requires fewer iterations to reach a solution as well. Okay, so next is the third one is, when it comes to accuracy, the Gauss-Seidel method is also known to be more accurate than the Jacobian method. But okay, let's see why. Okay, so this is because the Gauss-Seidel method usually utilize updated values on the variable as soon as they become available during each iterations. Okay, in contrast, the Jacobian method uses the previous iteration values throughout the entire iterations. And not only that, as a result of that, the Gauss-Seidel method takes the advantage of more up-to-date information and tend to produce more accurate solution. So with this, we can know that the value of the Gauss-Seidel method is way more accurate as well. Okay, so this is all for my part. Thank you.